Welcome back, students. We'll be looking at section 3.1, practice problems for linear equations and rectangular coordinates. The first thing we're going to do is look at a data graph and answer some questions. So number one says, between what years does the graph indicate an increase in rate? We're going to specifically look for those places that show an incline, an increase in rate. The first section is between the year 6 and the year 7. Our second grouping of increase is between the year 8 to the year 11. Then we're asked, between what years does the graph indicate a decrease? So let's see here, where it actually decreases in height. We have two sections here. Our first one is from 07 to 08. And then we have from 11 to 12. The final question says, what was the change between 06 and 11? So the specific area that they're talking about here is going to be between, let's see if I can change my color here, between 06 and 11. So between this area here. So we need to look at our starting point, which is right here, just above the 3, and our ending point, which is just below that 6. So we have, let's see, just above the 3 is probably roughly 3.2, somewhere around there. And then just below the 6 is probably, roughly, well, you know what, we'll just go with 6. It's close enough, I'm just going to say 6. The difference between those two gives me roughly a 2.8% increase. Because it did incline, we had a positive movement upward. 09 and 12. So I'm going to erase the green here so we can compare 09 to 12. Let's see, where's 09? Oh, there it is. We're going to go from here to here. So in 09, we started at roughly 5. Is it 5? Yeah, roughly 5. And then in 12, we're at roughly, I would say 4.6. Okay. So we're going to be roughly at a loss of 0.4. So roughly 0.4, a loss, so that's a negative number, percent. Now let's look at determining whether an ordered pair is a solution for the given equation. So in number 2, we have our coordinate is 4, 2. Remember, the 4 is our x, the y is, the 2 is our y. So now we just need to plug those in. So I have 2 times 4 minus 2 equals 6. 2 times 4 is 8, minus 2 equals 6. 8 minus 2 is 6, and then we have the equal 6 on the other side. Is that a solution? Yes. So that is a solution coordinate for that equation. Number 3, we have 2 and 1 this time. So I'm going to label my x and my y. I have 4 times 2 minus 3 times 1 equals 6. 4 times 2 is 8. 3 times 1 is, a negative 3 times 1 is a negative 3. And we have 6. 8 minus 3 is 5. And then we have the equal 6 on the other side. Is that a solution? No, 5 does not equal 6. So we'd say no, that coordinate is not a part of that line. All right, let's look at our next one. So we have negative 8 for x. We have 2 for y. So negative 8 And then 2 times 2 is 4. Is negative 8 equal to 4? No. So that coordinate is not a solution to this equation. Now we're going to practice completing each ordered pair for the equation. So we're going to plug in the one value that we have to find the value that we don't have for this particular equation here. So I'm going to write out y equals negative 4x minus 4. I'm going to plug in the 0 for the x because it's in the x location. So y equals negative 4 times 0 minus 4. Y equals negative 4 times 0 is 0, and then we still have the minus 4. So y equals negative 4 in this problem. Now we're going to use the same equation because we're using it for all 4 of these, but we're going to plug in a different value. This time we have y. So I'm going to plug in 0 for y and then solve for x. I'm going to add 4 to both sides. I get 4 equals negative 4x plus 0, which is just 4 equals negative 4x. Divide both sides by negative 4. And I get x equals negative 1, because that 4 divided by 4 is a 1, and we had that 1 negative, so that's a negative 1. So our x value is negative 1. All right, let's look at the next one. This time, for the same equation, we have a negative 3 for our x. So I'm going to plug that in. So negative 4 times negative 3 minus 4. Y equals negative 4 times negative 3 is a positive 12. 12 minus 4 is 8. So our y value in this one is 8. The next problem, they give us a y value. So I'm going to plug that in to the same equation. So we have 16 equals negative 4x minus 4. I'm going to add 4 to both sides. I get 20 equals negative 4x plus 0, which is 20 equals negative 4x. Then I'm going to divide both sides by that negative 4. And I end up with x equals negative 5. So I'm going to put that in my blank there. So this just demonstrates that with the same equation, depending on what values are used, you can get different values for the other part of your coordinate. Now let's look at a couple examples of completing tables of values for given equations. So I have the equation 3x minus 5y equals negative 15. And then I have these separate values that I'm going to plug in and find the other value. So the first time around, I'm going to plug in 0 for x because that's my first set that I'm looking for. So I have 3 times 0 minus 5y equals negative 15. 3 times 0 is 0, minus 5y equals negative 15. Rewrite that for the next step. All right, divide both sides by negative 5, and I get y equals 3. So for this grouping coordinate, I have my y is 3. The next one, we're going to have a 0 for y. So I'm going to plug that in, and we're going to find our x. So 3x minus 5 times 0 is 0. Rewrite this so that we can do our next step. Divide both sides by 3, and I get x equals negative 5. So I'm going to put that in my box here. The last time around, we've got a negative 6 for a y. So 3x minus 5 times negative 6 equals negative 15. 3x, we have a negative 5 times a negative 6, so that's a plus 30 equals negative 15. Subtract 30 from both sides. And we end up with 3x plus 0 equals negative 45. That gives us 3x equals negative 45. We're going to divide both sides by 3. And we end up with x equals negative 15. For that empty spot. Now let's look at number 10. On number 10, we have x plus 9 equals 0. The first thing I need to do is get x by itself. Then we'll go from there. So I'm going to subtract 9 from both sides. And I get x plus 0 equals negative 9. So x equals negative 9. All right. So I now know that for each of these. I'm just going to write x equals negative 9 because we've already done that. Okay, so I'm going to draw an arrow. All right, so now comes the part of solving the problem. So remember, if we don't have a y, what we need to do is write x plus 0y equals negative 9. And remember that 0 times the y just is 0. So I'm not changing the value of the problem. I'm just giving us a location to plug in our y. All right, so we have x plus 0 times 6 equals negative 9. X plus 0, because 0 times 6 is 0, equals negative 9. So x equals negative 9. All right, so for this one, I've got negative 9. Let's do the next one. We've already found that x equals negative 9 when we moved our minus 9 from both sides. So now we're going to change our equation to x plus 0y equals negative 9. X plus 0 times 2, because that's the y value in this second grouping. 0 times 2 is 0. So our x equals negative 9. Hopefully you're starting to remember that we did one like this in the terminology and what I had told you. But let's go ahead and do the third one and see if you remember what we had talked about. So we have x plus 0y equals negative 9. X plus 0 times negative 3 for this one. All right, so x times, 0 times negative 3 is just 0. So x is negative 9. All right, so hopefully you remembered that when you have an equation like this, that your x will always be negative 9, okay? So if you have an equation like this, just remember you need to subtract the 9 from both sides to get your x by itself. And then if you end up with this situation, all your answers will be negative 9. And the same can be said for y. If you have y equals a number and you don't have an x in your equation, then all your y's will be the same number. All right, let's look at giving the ordered pair for each letter. Let's find our coordinates, basically. So we have, let's change colors, x and y, okay? So A, we had to go over to negative 5 for A. Let me do that in blue because that's our x value. I don't want to confuse us. So we went to negative 5. Then we had to go up to 6. So our coordinate is negative 5, 6. B, let's see, where's B? Oh, there it is. Let me erase this. So when we get to those other coordinates, we're not confused. All right, so B, we had to go all the way over to 7. So B is 7. And then we had to go down to negative 9. So that is our y. C. C is, it's right here, right in the origin. So it's actually going to be fairly simple. It's 0, 0. It didn't go anywhere. Now let's find D. D is here. So we're going to go all the way to -8. And then we're going to go down to -4. Let's see, now we have E. We're going to go, oh, there's E, to 2. Then we're going to go up to 3. All right, last one is F. We will go to the left to -4. And then we're going to go up nowhere. We don't go up. So our Y is 0. All right, guys, that's the end of this practice video. Let's look at our quote. The enchanting charms of this sublime science, mathematics, reveal only to those who have the courage to go deeply into it. Carl Friedrich Gauss. All right, hope you guys are having a great day. I'll see you in the next video. Bye.